Okay, it is busy coming up there. Now, guys, in number 5, you actually had to work with the exterior angle of a cyclic quad a lot. So I'm hoping that you guys recognize that. So you had this picture. I'll just show you quickly the diagram that was given. So we have 2 circles, a smaller one and a bigger one. Do we notice that we have, oh, there was also a B missing over there. I'm hoping that you guys realize that that point there was B. They did say B1 is equal to X. So that is how you could have figured out that that was B. All right, we have 2 cyclic quads in here actually. That one, A, B, C, F, that is definitely a cyclic quad, right? Do we see that? Because all 4 points lie on the circumference of the small circle. And then CFED is also a cyclic quad because all 4 points of that quad lie on the circumference of the bigger circle. Okay, so now in the first question, they asked you to determine with reasons 2 other angles equal to X. All right, and the one that was given was B1, which is over here. Now, guys, B1 is actually an exterior angle of this cyclic quad. Do we see that? And we know that the exterior angle of a cyclic quad is equal to the opposite interior angle. Now, the way that it is sometimes confusing to find which one the opposite one is. So you look at the angle that's next to it, which is B2 in this case, and then the angle opposite to B2 is F1. All right, so F1 is also equal to X. And that was because of exterior angle of the cyclic quad. But now, guys, this F1 that we've just filled in here is actually also an exterior angle of the bigger cyclic quad, right? Which you might not have noticed. Do we see that? We have this cyclic quad in the bigger circle. And if we extend that line, they did tell us that AFE was a straight line, all right, in this paragraph here. So if we extend one of the sides of the cyclic quad, that outer angle is an exterior angle. So this exterior angle is going to be equal to the opposite interior angle. So you look at the angle next to it, which is F2, and the angle opposite that one is then D1. So D1 was also X, also because of exterior angle of the cyclic quad. Okay, so those are the 2 angles that I found. I'll just show you where I wrote it out. There we go. So this first cyclic quad was, I'll just put the name there. You know, you don't have to do that for the reason. It's just nice to keep track. This was for ABCF. And then the second cyclic quad was the bigger one, which was EFCD. Yeah, we find out that first one. Right, then in 5.2, they now wanted us to prove that this bottom shape, BCDG, is a cyclic quad, that one over there. Now, guys, what we actually have here is an exterior angle of this quad, that one there, right? Do we see it's one side of the quad that's been lengthened, that's been extended, and the outside angle there is X. And isn't that equal to the opposite interior angle? Yes. All right, so because of that, we can see that this bottom shape is actually also a cyclic quad, even though there isn't a circle drawn through those points. All right, that just means that we could draw a circle through those points. Okay, so D1 is equal to B1. D1 would be the exterior angle, B1 would be the opposite interior angle. Because they are equal, this is a cyclic quad. All right, so there we go. D1 is equal to B1. Therefore, BCDG is a cyclic quad. Converse exterior angle of cyclic quad. If you wanted to put an angle or a reason here, sorry, you could have said from 5.1 if you wanted to. Sorry, there's something underneath this page. Let me just, there we go. Okay, but you didn't need a reason there because you proved in the previous one actually that they are equal. Yes?
I don't understand when you converse because I just said exterior angle of cyclic quad.
So converse you always use when you're proving that it's a cyclic quad. You can't just say that because this reason is something that you use if you know that it's a cyclic quad already. Okay, so this is used to calculate stuff. Converse is used to prove that it's a cyclic quad. Okay, then in 5.3.1 and 5.3.2, Again, I used exterior angle for both of them. And it was maybe a bit difficult to see because now we actually had to work with this cyclic quad that we proved at the bottom. Okay, so for 5.3.1, they said join BD. Let me just do that quickly, get a ruler. So they wanted us to join these 2 points, right? And then prove that GBD is equal to E. So they want us to prove that that angle over there that we've just created, it's not X, right? GBC is X. Okay, so we're not proving now that something else is X. We're working with this angle here, which is not B1, it's GBD. Okay, that one doesn't have like a number name. So GBD, we need to prove that that is equal to angle E over here. Now, guys, this is a difficult one because now you need to use angles in same segment, even though there isn't actually a circle drawn there, which is a bit strange. But remember in the previous question, we've just proven that this shape here at the bottom is a cyclic quad. Okay, we have done one example like this before, but it was a while ago. We just proved that this is a cyclic quad at the bottom. So we could draw a circle going through those points. Now, guys, if each of these 4 points lie on the circumference of a circle, isn't GD going to be a chord of that circle, right? So GD is actually a chord of that imaginary circle, all right? It's a circle that we could draw there, but it's not drawn in. Okay, and you can only do that if you've proven that something is a cyclic quad, even if it's not in the circle. Okay, so this would be a chord. Now, guys, do we see that this chord is then subtending angle GBD, right? And remember, this point is on the circumference of the circle because this shape is a cyclic quad. C is also on the circumference of that imaginary circle because these 4 points form a cyclic quad, okay? So GBD is being subtended by chord GD, but then also C2. Just take a look at that. This is a chord. Remember, we're imagining that there is a circle going through these points. So that is an angle at the circumference, and that is an angle at the circumference, right? So those two angles are going to be equal. So GBD is equal to angle C2. Angles in same segment, okay? Even though that circle isn't there. The fact that we proved that it's a cyclic quad means that we could draw a circle there. All right, so we treat GD as if it's a chord because essentially it is. We just can't see the circle. And we treat those two angles as if they are at the circumference because they would be of that imaginary circle. Okay, and remember we're trying to prove that this angle is equal to E. Now we look at C2, and C2 is now actually an exterior angle of this bigger cyclic quad. Right, I proved that this one is equal to C2. Now I'm trying to prove that C2 is equal to E. All right, so C2 is the exterior angle, C1 is next to it, and the opposite angle to C1 is E. All right, so there we have it. First, we prove that GBD is equal to C2 because of angles in same segment. They're both subtended by this chord. Then we say C2 is equal to E because of exterior angle of cyclic quad. So if they're both equal to C2, then obviously they have to be equal to each other. Okay, so that is how I wrote it out. GBD is equal to C2, angles in same segment. I'm just going to add here, subtended by chord, what was that? GD. Okay, so that is difficult to see, guys. I realize that it is, but it is something that often comes up. All right, often they ask you to prove that something is a cyclic quad, then you need to work with angles in same segment in that same cyclic quad in the next question. Okay, so it's important that you are copying that down, please, if you didn't get to it. And then for 5.3.2, we actually had to do exactly the same thing. It was just working from a different chord, so I'll show you that again. I'm just quickly going to erase my dots and my extra stuff so that we don't get confused. Okay, I'll put this back up now. Just quickly for the next one. They now want us to prove that BDG, so this one over here, is equal to A, which is that angle there. I don't know why they put like a funny thing there. You can just ignore that. I'm not sure what that is. All right, but now we need to prove that this angle is equal to A. Now, guys, you're actually going to follow the exact same steps. Remember, BGDC is a cyclic quad. So then BG will be a chord, right? Because those 2 points lie on the circumference of a circle, and a chord is a line going from one point on the circumference to another point on the circumference. So BG is now the chord that we're looking at for this one. All right, BG subtends BDG. Do we see that? We have lines going from the end point of BG and they meet. Where they meet, they form that angle, BDG. But they also subtend, or that BD, that chord, is also subtending, BG, sorry, is also subtending C3. Also at the circumference, because C is also supposed to be on the circumference, right? So BDG is equal to C3 because of angles in same segment. They're both subtended by that chord. And again, C3 is now an exterior angle of the smaller cyclic quad. Right? The exterior angle is equal to the opposite interior angle, which is A. Okay, so the exact same steps as for the first one, 5.3.1, just working with different angles now. So this angle is in same segment. These two angles are subtended by chord BG. Okay, so first angle in same segment, then C3 is equal to A because of exterior angle. So therefore they are equal to each other because they're both equal to C3. Okay, do you guys have any questions so far? Right, these are tricky questions. It's important that we go through them. All right. Then just for the very last question there, they wanted us, or they just asked what type of quadrilateral is ABDE. So I just want to show you quickly. ABDE is now this whole big shape, right? After you've drawn NBD. So ABDE is there. Now guys, if we look at this, we have that angle GDB is equal to this angle at A. And isn't that the exterior angle? If this was a cyclic quad, right? That would be an exterior angle. And we see that it is in fact equal to the opposite interior angle in this whole quad now, okay, because that's the one that they're asking us about. So if the exterior angle is equal to the opposite interior angle, then it is a cyclic quad. And the reason for that will then be converse exterior angle, like we did at the beginning. Right, ABDE is a cyclic quad because of converse exterior angle of cyclic quad. The angles that I'm talking about here, actually both pairs of angles that we proved at the top. Okay, both of them were an exterior angle and then the opposite interior angle. So you could have looked at that pair and at the second pair. And guys, a question is often set up like that, where they ask you to prove something or calculate something, and then you need to use it in the next question. All right, so that's quite a nice thing. If you're feeling stuck and you're not sure of how to prove something, say it's a 5.3.3, go back and look at what you did before. All right, they call it scaffolding. They'll break the question up into steps that will help you get to the actual final thing. Yes.
As long as we get like one of the steps wrong, it'll show you.
Yeah, so often they'll say, that's why they're saying, prove that GBD is equal to E. So even if you can't prove it, you can still use it going on. Yeah. Yes.
So in that when it comes to broken up and you calculate like A or something in one question, and in the next question you have to use that answer. Like how do you show me to say A equals this, prove it?
You don't have to. You can actually just use it from the previous one, but if you want to, you can say from 5.1 or proven above or whatever. No, if it's written there, then it's fine. Yeah. Yes. You don't even have to refer to it. So in this case, for example, if you weren't able to prove that these two pairs are equal, you still need to realize, or you need to remember, okay, they said prove that they're equal, so they are equal, even though I couldn't prove that they're equal. So then you can use it in the next one. You don't even have to state it. Yeah. Okay, any other questions, guys? Right, let's do that proof quickly. The opposite angles of cyclic quad proof. And it's not a bad one. You just need to write it down. Proof number 4, yeah. So this is a new one. You didn't do this one last year. Let me just get my black pen here. Okay, so that is the theorem. We all know it. We've been working with it. The opposite angles of a cyclic quad are supplementary. So that's what we're going to have to prove. Okay, so I'm just going to draw the picture. If you guys can also copy it down. Okay, I'll just do it on the side here. Oh no, that's not good. Yeah, that's a very faint circle, but I think you guys get the idea. And then we're just making 4 points on the circumference. It doesn't really matter. It doesn't have to be exactly like mine. But we're making a cyclic quad basically. And we're just going to connect those points. Okay, that's all they're going to give you guys, a cyclic quad, right? So given, oh, and the center also, sorry, must just make an O there for the center. Okay, so again, just like we did the other day, everything that they're going to give you, I've done in black, and then everything that we need to fill in, I'll do in blue. Okay, the required to prove part, I think is quite obvious. We need to prove that if you add the opposite angles together, they're going to give you 180. So we need to prove that angle A plus angle C is equal to 180. But also we have another pair of opposite angles. So we just need to show that that pair also, if you add them together, will equal 180. Now for the construction, just like with the previous ones, we're actually going to draw in two radii, all right? And the radii, that we're going to draw in, we're going to do so that we can use angle at center. Okay, that's basically what this whole proof is going to revolve around. So we're going to draw BO and DO. And this is just an extra if you want. We are going to label the angles around O as O1 and O2. That's just so that the actual proof is a bit simpler to write down. It's not essential that you do that. Okay, so I'm going to draw those in. We're doing BO and DO. We tend to do constructions with dotted lines, but you can use a solid line if you want. Just make it clear that that's something that won't be given. Okay, you're going to have to remember to do that, please. The construction is always something that you must remember. Okay, and I'm just going to label the bottom angle 1 and the top one is 2. Or you could just work with BOD and then reflex angle BOD as the bigger one. Okay, so you could just use that if you want to as well. Okay, the proof. All right, guys, do we agree that angle O1 is going to be double angle A? Right, that's the first step. O1 is 2 times angle A. What is the reason there? Angle at center equals 2 times angle at circumference. And O2 is 2 times which angle? If O2 is the one at the center, which one is the one at the circumference? C, all right? It's that other diagram, which is a bit more difficult to see, but O2 will be double angle C because of the same reason. Okay, so O2 is equal to 2 times angle C. I didn't do it in one step now, but you could have, all right? Sorry, I just didn't think of doing that. So you could have said in one line, O1 equals 2A and O2 equals 2C, angle at center. All right, then you just have to write that reason once. Now guys, O1 and O2, if we add these two angles together, what should it give me? 360 degrees, hey, because the angles are on a point. So if I say O1 plus O2, that will give me 360. And I think you guys probably prefer using the reason revolution because it's shorter, but you can write angles around a point as well, that's fine. So I'm going to write down both here, but obviously you just choose whichever one you prefer. But now what we're going to do is we're going to replace O1 with 2A. And we're going to replace O2 with 2C. So therefore, instead of O1, we say 2A, because O1 is 2A. Plus, instead of O2, we're going to replace that with 2C, right? Because we proved that O2 is equal to 2C. So that is equal to 360 degrees. Now I'm going to take 2 out as a common factor there. Or you could just divide through by 2 if you wanted to. That also would have been fine. So what is A plus C going to be equal to? 180, right? I must move that 2 to the other side, and I'm going to divide by 2 because on this side I'm multiplying by 2. So if I move it, I'm going to have to divide by 2. So therefore, there we have A plus C is equal to 180 degrees. So 1/2 of our required to prove is done. Okay, does that make sense, guys? I'm just going to run through that again because the next part is just like a 2-line thing. It's very quick. So we say we create, or we construct rather, these 2 radii so that we can use angle at center, yes?
Let's say, is the cyclical quad going to be a small squarish shape? It's not so obvious.
They could do that, but they haven't done that before. Normally they keep it similar to what we have there. Yeah. Okay, so you construct those radii, then you say O1 or BOD is also fine, is equal to 2 times A because of angle at center. The other angle, O2, or you could say reflex BOD, right, is equal to 2C, angle at center. Then you say if you add these 2 angles together, it will equal 360 degrees because they are around point A. We know that angles around a point must add up to 360. Then you plug in, instead of O1, you're going to substitute 2A because we proved that O1 is equal to 2A. You do the same thing with O2. Instead of O2, you now write 2C because that's what we're trying to get to. Hey, we want to get A and C. We're not actually interested in the O's. Okay, so we substitute 2A and 2C. That's equal to 360. We take 2 out as a common factor, and then we divide by 2. Now, guys, I have mentioned this before, but we know that the 4 interior angles of a quadrilateral, any quadrilateral, all right, it can be a parallelogram, a cyclic quad, whatever, it doesn't matter. The 4 angles have to add up to 360. So we have that these 2 angles add up to 180. So what must these 2 angles add up to for all 4 to add up to 360? Also 180. Okay, so that's going to be the last thing. So you just need to write A. I'm going to write it in a specific order now. So A plus C plus B plus D should also equal 360 degrees. And the reason for this is angle sum of quad now. Okay, don't get confused and say angle sum of triangle. Suppose you could say in quad as well, angle sum in quad, angle sum of quad. Doesn't really matter. But we've already proven that this is 180. All right. So we have 180 degrees plus B plus D is equal to 360. So therefore, B plus D, if I now move that 180 to the other side and I minus it from 360, should add up to 180 degrees. So you can skip that middle step if you want. You can go straight from that line to that line. Okay, but this is just an explanation of how we get there, basically. All right, does that make sense? This one jumps around a bit more than the 3 that we've done so far. Okay, so you have to remember actually what you are doing here. It's not as intuitive, I think, as the other 3. But I think if you understand this, it should be all right. Okay, your homework, guys. Again, from the revision exercise, but now I want you to do number 6. So revision on page 213, that's the page that the question is on. All right, it's 7 separate questions and all the questions add up to 23. All right, so it's quite a long question. You have half an hour. You can definitely get through the whole thing in that time. All right, or you can spend some time trying to figure it out. It's again working with x's instead of values. Okay, those are harder to do, but it's important to practice them. I'll put the question on the board just now. Just make sure that you've copied this down fully, please. And guys, it's quite a nice idea. I know it takes time, but to actually draw the picture in your book, all right, so that you can fill stuff in, so that you can figure it out. It's easier that way, instead of just looking at the picture and trying to remember what you already calculated. Okay. Here we go. That's number 6. Yes. Yeah, so the wording will be prove the theorem that states, and then they're going to write the theorem out. Okay, so you will never have to wonder whether you have to do a proof or not. It will be quite clear on the wording. And usually they also give you like an answer sheet for the proof as well, like a separate thing that you were talking about. Okay, that's number 6, guys. Get going. You can listen to music if you want. I actually just, sorry, I'll put this back up just now. Yes?
Do they give you the question? Do they give you like an answer sheet that has the diagram on it?
Yes. Yes, yeah,
So
they
that'll
do.
be separate to our question paper.
You'll have to staple it to the back.
So they give you the diagram.
Yes.
Thank you.
No problem. I quickly want to show you. I actually don't. I think I showed the other group. I might have shown you. I can't remember now. If I have showed you already, then you can just tell me. There's a geometry summary note on the grade Google Classroom. So if you go to the grade 1, then you'll see there's a link to the zero-rated server. Okay, everything is on there as well, but I'm just going to click here. Then I don't have to wait for that to load. It's number 8, which is geometry summary. And all the different things are summarized here. So it's showing you when parallel lines are given, these are the kind of things to look out for. There are the correct reasons. When you have to prove that lines are parallel, then those are things that you can do, and those are the correct reasons. Information about triangles, when you must prove 2 sides are equal, it's giving you different scenarios and what you could have to look out for in those scenarios with the correct reasons. When the center of an angle is given, so here those are the 3 different diagrams for angle at center. Okay, so we've just looked at that one and that one in that proof. We used both of these kind of configurations. That one is just one that's a bit more difficult to see because the angle at the center and the angle at the circumference are next to each other. Okay, but that's still something that you must be able to do. Here we're working with line from center perpendicular to chord and line from center to midpoint of chord. That's theorem 1 and 2. All right, we proved both of them. Just showing here that if you have radii, then they're equal. That the radius is perpendicular to the tangent. Here, if you have an angle subtended by the diameter, it's 90 degrees, and those are the reasons. We've been working with this reason, but you could also write that if you want to. I think everyone's fine with this one though. Angles in same segment, just a diagram just showing that. Here is the equal chords, equal angles thing, which we haven't worked with a lot, but it has come up once or twice. Remember, if you have multiple chords, but they're the same length, then they will subtend the same angles. And guys, that actually happens if you have different circles as well, but the 2 circles have to be equal. All right, so we've often worked with 2 circles where one is small and one is bigger. All right, in that case, you couldn't use this. But if you have equal circles, so that's what that first line says. If A, B, C, and D, E, F are equal, so the circles actually are the same, they'll have to tell you that. And then you have equal chords in the 2 different circles. But remember, the circles are also identical, the same. Have the same diameter and so on. Same chords, then those will also subtend the same angles. And the reason is the same, equal chords, equal angles. Here, working in a cyclic quad, right, there's some notes. How to prove that a quad is cyclic, there are the 3 ways. All right, there's a picture and then stating exactly if this is happening, then that will be a reason, if this is happening, and so on. Here's a summary of tangent stuff. So tangent perpendicular to radius, tangents from a common point. Remember, they're equal in length. And then tan chord theorem, there are 2 pictures showing that. And then how to prove that a line is a tangent. There are two ways of doing that. So those two are there. Okay, so if you're having trouble, this is quite a nice thing to study also when you're studying for a test. All the circle stuff is basically summarized on here. The proofs obviously just aren't on here, but the proofs you have in your book. Yeah.
I was studying in this section.
No, we're actually going to do more. So I must do the last proof, and then we're just going to do some more practice. Okay, so we're going to have to start the new section on Monday, unfortunately, which is not great. All right, but we have to because we're doing trig, and trig is a huge section. We can't really waste time on that. And then your test is Tuesday. Okay. So guys, you've had a lot of time to practice in class, at home. We can't afford to do another revision lesson on Monday, but there's videos of everything that you need. So, yeah. Okay, get going on that, please. Number 6.